Okay, so now we are ready to start talking about elastic collisions. Now some of the work here is going to be very tedious, so be patient, take your time, pause whenever you need to, and make sure you understand each of the steps. Okay, so first of all, if a collision is elastic, we know that we can use KEI equal to KEF. And again, if F external is equal to 0, then we can use Pi also equal to Pf. Okay, so the main thing, what makes it an elastic collision is this fact that the kinetic energies are equal in the beginning and at the end. Okay, so make sure you always keep that in mind. So let's apply all this to a problem. Let's take an example. Let us say that I have a 1 kg block that is moving to the right at 10 meters per second, and it collides with a 4 kg block that is initially at rest. Okay, so this is the before picture. Here's my example. And after the collision, what you've been told is that the collision is elastic and they're both moving with some velocity. Let's say the velocity of the second one is v1, of the first one is equal to v2. We do not really know what the directions are, but our goal is to find the two velocities. So this is 1, this is 2. You've been told that the collision is elastic. Okay. So what we have is we have two unknowns in the problem. Okay, so at this point you have to ask yourself, if I have two unknowns, how many equations do I need? Alright, and if you answered that you need two equations, then you're on the right path. Okay, so since we have two unknowns, we need two equations to figure out the problem. So we're going to get our two equations using our two conservation laws. Let us first use Pi equals Pf. Okay, because once again the net external force is 0, so I can do this. Okay, so let's write down the total initial momentum. The total initial momentum is going to be 1 times 10 plus 4 times 0, because the second block is not moving. And then the final momentum is going to be equal to 1 times V1 plus 4 times V2. Make sure you understand this step. Okay, once again, the total initial momentum, the beginning, the 1 kg is moving with 10, the 4 kg is at rest. So that is why we have 1 times 10 and 4 times 0. At the end, the 1 kg has a velocity of v1, the 4 kg has a velocity of v2. We really do not know what their directions are, and so we're just going to leave them as, leave them as positive values. And then when you solve for v1 and v2, if the sign is negative, then it simply implies that one of them was going to the left. That's all. Alright, let's simplify this, and we can rewrite this as, the left hand side becomes 10, the right hand side now becomes v1 plus 4 v2 is equal to 10. Alright, this is equation 1. Good, we're on the right path now. Now let us use KEI equals KEF. Remember, I do not put the vector sign on KE because kinetic energy is a scalar quantity. Alright, let us write down the total initial kinetic energy. At this point, it would be a good idea to ask, hey, what is the formula for the kinetic energy? And if you said 1/2 mv square, they are on the right path. So let's write down the total initial kinetic energy. It is equal to 1/2 times 1 times 10 square plus 1/2 times 4 times 0 square, and the final is equal to 1/2 times 1 times v1 square and 1/2 times 4 times v2 square. Great, so we have our kinetic energy equation. Now at this point, okay, what I would recommend is that do not start multiplying everything by half, do not just combine all the terms. It's always a good idea to simplify things. It's always a good idea to get rid of things if you can. For instance, in this case, you see everything has a factor of half in front of it. We can multiply everything by 2 and get rid of the halves. So let's do that. So that's the first thing we do. Now that we've done this, what you end up getting is 100 on the left hand side, and on the right hand side you have a v1 square plus 4 times v2 square. Okay, and just for purposes of making things look nice, we're going to rewrite this as v1 square plus 4v2 square is equal to 100. This is equation 2. Now, our goal is to simultaneously solve equation 1 and equation 2. From here on, the algebra is actually very straightforward, although a little tedious. Okay, so be slow, just follow each step along the way, and then you should be fine. So the first thing we'll do is we'll take equation 1. You always take the linear equation and then find V1 from the first equation and substitute into the second. Now, common mistake that people end up making here is that they say that, hey, we can just take the square root of the second equation on both sides, okay, and we'll get V1 and 2V2 equals to 10. Okay, that would be completely incorrect. So you cannot take the square root of the left hand side and just expect to get simply V1 plus 2V2. Okay, that would be completely incorrect. So what you need to do is you have to solve it simultaneously. So what we observe is from equation 1, V1 equals 10 minus 4 V2. We take this and substitute it into equation 2. So let's substitute into equation 2. So what we'll do is we'll take this V1 here and we'll replace it with all this stuff. Alright, so what you have is you have 10 minus 4 times V2 the whole square, plus 4V2 the whole 4V2 square is equal to 100. Alright, so once you get this to this stage, we need to figure out how to evaluate this correctly. Okay, now if you remember, we have a simple equation which says that a minus b the whole square, okay, we can rewrite this as a minus b times a minus b, and in order to do this correctly, you have to multiply the factors out correctly. So you do a times a, that gives you a square. Then you do a times minus b, and that gives you minus ab. Then you do b minus b times a, and that gives you minus ba. And then lastly, you can do b times b, and that gives you plus b square, because you have a minus b times minus b, and that gives you plus b square. And when you combine all this together, you end up getting a square minus 2ab plus b square. Now, you can either use this formula directly in here, or you can set up a system like this on the left hand side and then find this out correctly. Okay, either ways you will end up getting the same answer. Make sure you end up getting the same answer. Alright, so at this point it might be a good idea to pause, calculate the square of this term, okay, and then proceed. Now what I'm going to do is I'm going to move on. So I'm going to rewrite this as, first that it's going to be 10 square, because my 10 is my a and this is my b. So I'm going to write this as 10 square minus 2 times 10 times 4v2 plus 4v2 the whole square. And this plus, now this is simply the square of the term. Do not forget the second term. This 4v2 square is equal to 100. Alright, if you're confused about this, at this point just stop, maybe get help from someone in the class, and make sure that you figure this out. Okay, so now I'm going to proceed. It's going to get 100 minus, or 2 times 10, 20 times 4 is 80. So I get negative 80 v2 plus 16 v2 square plus 4 v2 square is equal to 100. Now what happens here is that things get cancelled. So I can get rid of the 100. Sorry, oops, wrong thing. I can get rid of the 100, and then I can combine these two terms and end up getting 20 v2 square minus 80 v2 equals 0. Okay, alright, great. We're very close to the end now. Now what you can do here is you can factor out the common thing. So you see here 20 times v2 is common to both, and when I factor 20 v2, I am left with v2 on one side and I am left with 4 on the other side, and all this becomes equal to 0. So this implies that 20 v2 equal to 0, or v2 minus 4 equal to 0, because this is a product of two things, and what we know is that if a times b equals 0, a is equal to 0 or b is equal to 0. Great. So now V2 is equal to 0 or V2 is equal to 4 meters per second. So we got one set of solutions, okay? We only found V2. Now our goal is to find V1. If you remember, V1 was equal to 10 minus 4 times V2. Okay, so let's find V1. So V1 is equal to 10 minus 4 times 0, so which is equal to 10 meters per second. So that's one option. Or V1 is equal to 10 minus 4 times 4, which ends up being 10 minus 16, ends up being equal to negative 6 meters per second. So we have two solutions. Solution 1 is V1 equals 10, V2 equals 0. Okay. Or the solution 2, which is V1 equals minus 6 and V2 equals 4. Okay, so let's analyze this and then we'll be done with everything. Now if you look at solution 1, what it says is after the collision, the speed of 1 continues to remain 10, because you see V1 was originally moving at 10 meters per second to the right. Okay, and after the collision, its velocity is still 10. And on the other hand, V2, which was originally at rest, continues to remain at rest. So this solution implies that there was no collision. Physically nothing happened. They completely missed each other. The second one, on the other hand, says that there was a collision. So this is the solution that we will use. Okay, so this is how you end the problem. So make sure you understand this. Okay, and if you understand this, I want you to proceed and do the two of these following problems. Okay, do it in their entirety, check with each other, and hopefully you got the right answer. And you can also check, go to the website and check the notes, and I think in the notes you'll find the answers to a couple of these questions. Okay, so make sure you finish them off. Alright, so here's one of the problems. You have a 1 kg block moving to the right at 10 meters per second, and you have a 3 kg block that is at rest, and the question is find V1, V2 after the elastic collision. Okay, and then once you get all this done, repeat this for this problem. You have a what was it? You have a 1 kg block moving at, I think, 5 meters per second, and then a second 1 kg block that is at rest. Okay, same thing again. Find V1, V2 assuming elastic collision. And then here's a third one. This is slightly non-trivial. Okay, although it falls in the same category. You have a 2 kg block here that is moving to the right at let's say 5 meters per second, and you have a 1 kg block that is at rest, and the question is find V1, V2 right after collision assuming that the collision is elastic. Okay, so finish these things and check with each other, and then hopefully you will have a good grasp of this. All right, that's it.